We're letting everyone in. Welcome all. Welcome to the second of our EMBRACE Roybal Center sponsored webinar series. We're excited to continue our conversation with today's topic, examining mechanisms of intervention impact using statistical mediation methods. Can we move to the next slide? Just want to share our funding disclaimer here. We'll move to the next slide. My name is Nancy Hodgson, and along with Dr. Laura Gitlin, we co-lead the Behavioral Intervention Development Core of the EMBRACE Roybal. Our lead PIs are Joe Gaugler and Andrea Gilmore-Bykowski. The mission of EMBRACE is to advance research capacity for mechanistic-based, home and community-based dementia care interventions. EMBRACE's first major activity is to fund and support trials that rigorously evaluate complex, individualized dementia care interventions. Next slide, please. And to that end, we will have our pending letter of intent call that will be coming out in a few weeks. So please be on the lookout for that call on our website and in emails. The call will specify the due date, and that will be sometime in October. Our second major activity is to provide educational resources to support researchers in developing and implementing behavioral intervention studies. And to that end, I'm pleased to welcome today's webinar presenter, Dr. David Roth. Dr. Roth is a professor emeritus in geriatric medicine and biostatistics at Johns Hopkins University. Trained as a clinical psychologist, Dr. Roth also brings considerable expertise as an applied statistician with over 40 years of expertise as an NIH investigator. He brings also considerable collaborative contributions in addition to being a PI on multiple R01 grants that examine the health effects and benefits of family caregiving using data from large national epidemiological investigations. Although Dr. Roth retired from his full-time academic position in 2024, he continues to be an active scholar and serves as a consultant on multiple funded projects, including the EMBRACE Roybal Center. He's had a long collaborative history with the EMBRACE Center leaders. For today's presentation, Dr. Roth will introduce investigators to key decisions that must be made when testing intervention mechanistic hypothesis using statistical mediation methods. Topics will include whether change scores or post-treatment scores should be analyzed, how baseline pre-treatment measures should be used as covariates, the importance of selecting mediating variables with very high reliabilities, and the availability of multiple methods for testing the statistical significance of and interpreting the magnitude of the mediated effects. We will hold time for a moderated question session at the end using the raise hand function, or you can also type your questions in chat. Turning it over to you, Dr. Roth.
Okay, well, thank you, Nancy, for that wonderful introduction. And it's certainly my pleasure to be presenting to the EMBRACE team and audience on mediation modeling. I think the first thing I need to do is share. Is that right, Katie?
Yes,
Yep, you got it.
Let's see here. All right, can you all see my title slide appropriately?
Yes, it's good. It's good, David.
Great. Okay, so yeah, the title of my talk is Examining Mechanisms of Intervention Impact Using Statistical Mediation Methods. And let's see, how do I advance?
I think if you just click your arrow button, like one arrow forward.
Yeah, that's what I'm trying. Let's try again. Okay, there we
you
go.
go.
And I have no disclosures to report. You'll hear later on in the talk that I'm a big fan of the M+ software package for testing mediation models. Maybe I should be on the M+ payroll, but I'm not yet. All right, the outline of my talk, I'm going to review some of the basic concepts and terminology of mediation modeling. Briefly illustrate how these models are perfect for testing intervention mediation effects using multi-wave pre and post 1 and post 2 randomized trials of interventions. Then I'm going to spend most of the time talking about some specific considerations when you do mediation modeling, whether you should analyze change scores or just the actual raw scores after intervention. If you have baseline values available, whether they should be used as covariates. Talk a little bit about testing the statistical significance of the mediated effect. That is the effect of the intervention that can be explained by its impact on the mediator, transmitting through to the primary outcome. I'm going to mention just a few times that it's okay to examine mediation even when the overall intervention effect did not have a significant effect on the primary outcome. Originally, 40 years ago when Barron and Kenny first started talking about mediation modeling, sort of step one was you had an overall total effect of the intervention or the primary predictor of interest that was statistically significant, and then you wanted to understand the mechanisms of that impact. But subsequent researchers have shown that sometimes the overall effect is not in fact significant, yet you still do have a significant mediation effect if you are smart enough to go ahead and test for that. And I certainly think that's a worthwhile option. So you're not immediately stopped cold when the overall intervention effect for some reason is not statistically significant in the entire sample. I'm going to mention that it's important to pick mediators that are measured well, very well, really. Unreliability in the mediator can cause some really serious biasing effects on the effects being estimated. And I'm going to talk briefly about one approach to handling this problem is to extract latent mediator variables instead of using observed variables. Not always possible, not always feasible, but if with some forethought, sometimes it can be part of the plan and can provide some real benefits in terms of statistical power and better precision in the estimation. And I'm going to mention also briefly that although 90% of my talk is going to be assuming that both your mediator and your outcome variables are sort of continuous quantitative variables, sometimes outcomes are our primary outcomes are binary variables, logistic regression type outcomes, or time to event outcomes, such as in a survival analysis. And mediation analyses can also be applied in those cases with some, a few important adjustments. And I'm going to go through 3 different examples today that I'll talk about more closely when we get into those examples. The learning objectives, I hope that those of you who are listening on today and in any recorded version of this talk will understand the principles and concepts when testing mechanistic hypotheses with mediation modeling, that you'll be able to select from the various options that are involved, including whether you should use baseline covariate adjustments, whether you should analyze change scores, the timing of the different data waves to take advantage of kind of the causal hypotheses that are involved in mediation modeling. And again, the importance of selecting mediators that have very good psychometric properties. And we'll spend a little bit of time talking about how to approximate the sample size that is needed to plan a trial that is going to involve some mediation testing. So first, the basics of the statistical mediation modeling. So here we have an intervention versus a control condition and an effect, a total effect, so-called total effect on the outcome that is usually illustrated by the letter C in the mediation modeling. What we want to do is take that total effect of the intervention on the outcome, the effect C, and partition it into a proportion of that effect that might be explained by the intervention's effect on some mediating variable. And the path from the intervention, the effect of the intervention on the mediator is illustrated by path A here. The effect of the mediator on the outcome is path B. And then the so-called direct or unmediated effect is here illustrated as C prime. So as I mentioned, the total effect is illustrated by the estimate for letter C. The direct or unmediated effect is C prime. And then the mediated or indirect effect is usually calculated just by the product of the A times B path. Sometimes we're also interested in calculating the percent of the total effect that can be explained by the mediator, the proportion mediator that is just A times B divided by the total effect C, or in this case, A times B plus C prime. So again, this is all very basic terminology and standard labelings and letterings for the different paths involved in a mediation analysis, not only in intervention research, but in other research contexts as well. Nothing at all new here. In applying mediation modeling to RCT type designs, here's a simple example where we are using baseline measures as covariates, both for the mediator and for the outcome. And this is an illustration where we're only having two waves, a baseline wave and then a post-treatment wave, where the mediator and the outcome are measured at the same wave. Perhaps not ideal, but sometimes that is what you have. And in a couple of the examples I'll go through today, indeed, that's what we did have. One point I'm going to illustrate a couple of different times today is that another option is not to analyze those post scores, but to analyze changes from baseline. So here, delta M and delta Y represent post minus pre-score changes on the mediator and the outcome variable, respectively. So the A path is the same whether the post score or the change score is analyzed, as long as the baseline is a covariate. But the B paths and the C prime paths become different whether change scores or post scores are analyzed. So that represents, one change or one option that you have to choose from. Do you want to analyze change scores or do you want to analyze post scores? Some people have learned that in a typical analysis of covariance, the analysis is the same, whether change scores or post scores are analyzed, as long as baseline is included as a covariate. And indeed, that is true for the basic ANCOVA that's illustrated in the top part of this diagram, the A path. But the B path and the C prime path become different, whether change scores or post scores are used. And I'm going to recommend that most often, where feasible, you use change scores, that I'll explain a little bit later. So there's these topics illustrated in a two-wave design. Perhaps a better design is when you have at least three waves of data, a pre-baseline assessment, an initial post-intervention assessment where we're expecting to see changes on the mediator, and then a second longer-term assessment where we'll want to test the effects of the intervention on the primary outcome variable. So here we've got the mediator measured at the first post-randomization assessment and the outcome measured at the second post-randomization assessment. Again, if change scores are used, then that is going to change the estimation and the significance of the B path and the C prime path. And here is another mediation model where instead of now an observed mediator, we're using a latent mediator variable. Here's an example where we're assessing a latent change score for the mediator based on three different observed change scores for three different observed mediator indicators. Again, this is an example where I think this model has a great deal of potential and power and increased precision if you have multiple measures of the mediating process. Those multiple measures and their change scores should be at least moderately correlated to support the extraction of a latent variable from those sort of overlapping or common variance components. If you have anticipated a certain process, have multiple measures of that process, and can extract a latent mediator, there are certain advantages to that in terms of the power of testing mediation hypotheses. In terms of testing the statistical significance of the mediated effect, there are a number of different options. I've illustrated three here. The first one is very simple. It basically is known as the joint significance test, which basically guarantees that if both the A and B paths of your mediation model are statistically significant, then you can be almost certain that the mediated effect itself is also statistically significant. Now that just uses a cut point, say, of p less than 0.05. You don't get a more precise p-value from that joint significance test, but that's a very simple, straightforward way to tell or to conclude, perhaps, that your mediation effect is at least statistically significant. A couple more statistical methods. There's the Sobel test, which is very commonly used. It was much more commonly used a few years ago. This is in a paper by Sobel. They provided a formula to calculate the standard error for the A times B, or the mediation effect, and then you divide your A times B effect by the standard error, which will then allow you to look up a p-value from a table of the standard normal distribution. It turns out that the Sobel test, although very popular and very commonly used, was probably overly conservative. And in a number of cases, there were mediation effects where the Sobel standard error was perhaps too large and didn't support the significance of the mediation effect. We know this from a number of studies that have been done consequently using simulation methods and so forth. And I've led to a third approach here on this slide, bootstrapping methods. Where in bootstrapping, you resample your actual data multiple times, but resampling with replacement. So the same participant might be selected 2 or 3 or 4 times in sort of random resampling of the data. You do that random resampling of the data, many, many times, usually thousands of times, and then calculate the A times B effect from each sampling. Now, again, obviously in modern computer software, you don't actually do it thousands of times. The computer does that for you, calculates that standard error from the bootstrapping method, and then you have a standard error, usually a smaller standard error than what you get from the Sobel method to test the significance of that mediated effect. Both the choices 2 and choice 3 are provided with ease from the M+ software that I use to test mediation modeling. That's a structural equation modeling package. That's probably the most popular way to do structural equation modeling these days. The Sobel test is given to you by default, but just with a one-line option, you can ask for bootstrap standard errors as well. And I think that's usually worthwhile to get them because they are typically more powerful than the Sobel method. All right, so now I'm going to do just a little bit of self-promotion here, perhaps. I'm going to point out that a lot of the points that I'm going to cover in today's talk, I published in a book chapter back in, I believe this was 2012, with David McKinnon, who's a giant in the field of mediation modeling, where we laid out a number of these models, particularly from the Mary Middleman project. So much of the remainder of the talk is material that can be reviewed and covered in more depth if you want to go get this book chapter and read more offline at your own leisure. In many of the examples in this book chapter, I use data that I was fortunate enough to be involved as a statistician, led by Mary Middleman from NYU, the NYU Caregiver Intervention Study. This was a randomized controlled trial of 406 spouse caregivers of dementia patients, and these patient caregiver dyads were randomly assigned to an intervention condition or to a usual care control group. The intervention condition was targeted on strengthening social support resources, using social support services, engaging other family members, other specific targets like that were designed to improve the social support resources and the satisfaction with those resources from these spouse caregivers, whereas usual care participants just received information and access to standard services. Of the 406 that were randomized, 312 spouse caregivers were still providing care in the home at least 1 year after the randomization. And it's these 312 spouse caregivers that provided data from community caregiving 1 year after randomization that are used in all the analyses I'm going to talk about today from this NYU caregiver intervention. And as I mentioned, changes in social support were hypothesized to be the important proximal or mechanistic outcomes and would explain more primary outcomes such as changes in caregiver depression and the patient nursing home placement rates. And one of the main mediators I'm going to look at today is a very simple measure of the satisfaction with social support that the caregiver reported. So 3 items were used to measure satisfaction with social support. In general, how satisfied are you? How satisfied are you with the assistance you get with daily activities? And how satisfied are you with the emotional support you get from your social network? And these 3 items are rated on simple Likert scales ranging from 1 to 6. We simply added up those 3 Likert score ratings to get a total satisfaction with social support measure. And then here's a mediation analysis that is covered in depth in our chapter from the longitudinal modeling book, where we found that the intervention did affect changes in depression 1 year later. but that intervention was highly mediated by changes in the satisfaction with social support ratings. And if you calculate the total effect and then see to what degree was that total effect mediated by changes in satisfaction with social support, we found that basically 30% of the intervention's impact on depression could be explained by the intervention's impact on changes in social support, and then those corresponding associations with changes of social support on changes in depression. So I'm going to return to the Mary Middleman project a little bit later and illustrate some of the consequences when you apply different modeling options. But before I do that, I want to go through a couple other applied examples today that illustrate some mediation modeling that I've been fortunate enough to do in collaboration with principal investigators who I believe are on this call today. And I'm glad that you're following with me and hearing how I summarize our work together. So one of them is the work led a decade or maybe even 2 decades ago by Laura Gitlin on the Beat the Blues intervention for depressive symptoms amongst older African Americans. So here's a slide that summarizes that study very briefly. Beat the Blues was a randomized controlled trial of 208 African Americans who were 55 years of age or older and had PHQ-9 scores of depression of at least 5 at baseline. And these participants are randomly assigned to a multi-component cognitive behavioral intervention or to a waitlist control condition. The intervention was delivered by social workers and targeted symptom recognition, knowledge of depression, stress reduction, and behavioral activation as the mechanisms or processes by which we were trying to reduce depressive symptoms in these African Americans. 179 of those 208 participants provided mediator and outcome data at 4 weeks after the onset of the intervention. And changes in knowledge about depression, changes in behavioral activation, and changes in anxiety were hypothesized to mediate the effect of the intervention on changes in depressive symptoms that were measured by both the PHQ-9 and the Center for Epidemiological Studies Depression Scale. In this paper, we analyzed the mediators both individually and then picked the significant ones and analyzed them jointly to get sort of a total package of how much of the intervention effect could be explained by moving these different mechanistic hypothesized mediators. So here's the basic mediation model that we used in the Gitlin Beat the Blues project, seeing that, although it looks like change in mediator was measured before changes in depressive symptoms, they were in fact both measured at the same 4-week outcome assessment, or I'm sorry, 4-month outcome assessment. This is table 3 from that paper, where we found that for both the PHQ-9 and the CESD depression measure, we had significant mediation occurring for behavioral activation, depression knowledge, and anxiety. We also looked at changes in formal care, and that wasn't a significant mediator at all. If you look over here at the proportion mediated, for the significant mediators, you can see that the mediated effect ranged from, looks like the lowest one there is 33% up to 41%. So actually rather similar to what we found in the Middleman project, where about 30% of the intervention effect on depression was mediated by changes in satisfaction with social support. In this case, about 30 to 40% of the intervention's impact on depression was mediated by these 3 mediators individually: behavioral activation, depression knowledge, and anxiety. Now, one thing we decided to do in this project was to look at these mediators simultaneously. And when we did that, we found these results that are summarized in figure 2 here. And you can see that all 3, anxiety, depression knowledge, and behavioral activation, all 3 of them were significant mediators for the CESD. Only anxiety and depression knowledge were significant mediators for the PHQ-9. Depression knowledge and behavioral activation were somewhat correlated with each other. When we calculated, sorry, let me go back here. Oh, now we're in trouble. Here we go. When we calculated the total joint mediation across these 3 mediators, it was 60% for the PHQ-9 and 67% for the CESD. So remember, when you analyze them individually, they were about 30 to 40% each, but some of that is overlapping variance accounted for due to the correlations amongst these mediators with each other, and particularly depression knowledge and behavioral activation were somewhat redundant with each other. But when you looked at them all three simultaneously, all three had their own unique mediation pathways, and the sum of those mediation effects was greater than 60% for both PHQ-9 and CESD. The third applied example I'm going to talk about today is analyses on the Aging Plus intervention directed by Manfred Deal and his colleagues at Colorado State University. These data are very recent. This was just published earlier this summer in the journal Psychology and Aging. So a lot of the stuff I'm talking about today is 10 to 15 years old, but not this one. If you want a very recent example to go by, go pull up Manfred Deal's paper and all his supporting documents that are available online as well. I'll just give a brief introduction to what we did and what we found in today's talk. So here's a summary of the Aging Plus intervention as directed by Manfred. And there's a picture of Manfred, rather serious looking picture of the PI of this project. So Aging Plus was a randomized controlled trial of 335 adults between 45 and 75 years of age. And participants were randomly assigned to the Aging Plus intervention or to a health education control group. So in this example, unlike others, where we had either wait list or usual care, this one had actually had an active control condition where those participants did receive health education information that probably had some of its own benefits, which creates somewhat of a higher bar to move both the mediator and the outcome. But we were able to do that to some degree. The Aging Plus intervention aimed to improve physical activity of these older adults by targeting age-related motivational factors, and the motivational factors that were targeted, including the participants' own sort of negative views about aging, their self-efficacy and engaging in behaviors that were related to physical activity, and their behavioral intentions to actually become more active. Of the 335 participants, 278 provided physical activity outcome data at 8 weeks. And we looked at changes in these motivational factors measured at 4 weeks and looked at their mediation effects then that were hypothesized to mediate the effect of the intervention on the changes in activity on physical activity at 8 weeks. So one important point is that this trial also took advantage of the temporal ordering of the intervention, an earlier assessment of changes in the mediator, and then a later assessment of changes in the outcome, taking advantage of those temporal characteristics where you can perhaps more strongly interpret a more causal effect of changes in the mediator on changes in the outcome. We had a lot of mediators and several outcomes in this paper, so we actually ran 108 different mediation models where we looked at all possible 9 mediators for all possible 12 physical activity outcomes. So this was a very I don't want to say exploratory, but a very descriptive, fine-grained analysis to see which mediators might be transmitting the effect of the intervention on which of our many, many measures of physical activity that we collected at 8 weeks post-intervention. Here's the same mediation diagram, very similar to the ones we've used before, emphasizing that we did adjust for baseline or covariates at baseline, and we did look at changes post scores minus baseline for both the mediator and for the outcome. And this is a table from the Deal et al. Paper just published in Psychology and Aging. And this table illustrates the 16 different, of our 108 mediation models, the 16 different mediation models that had statistically significant mediated effects. So you can see here, there's the path A and path B. And unlike some of the other models I've already showed in today's talk, these are standardized paths, so they can be directly compared to each other. They're basically standardized effect size. So you can see that the path A, the effect of the intervention on the mediator, is roughly in the 0.35-ish range. And then path B, the effect of the mediator on the outcome, is a little bit smaller, 0.2 or even a little bit less, but statistically significant in all these models because these are the models that had statistically significant mediation effects. 16 out of the 108 is 15%, so probably a little bit higher than what you'd expect purely by chance. And we ended up, interpreting this as showing partial evidence for mediation. We would have liked to see more, but we saw several of them and never expected all of them to be statistically significant because we were looking at several different mediators and several different outcomes simultaneously, and not all of them were capturing perhaps the key mechanistic components of the aging plus intervention. We also used the bias-corrected bootstrap as conducted by M+ to test the significance of the mediation effect. And again, all of them were statistically significant in this table. These are the 16 significant findings. And although not calculated here too, if you calculate the proportion of the intervention effect mediated by these mediators on these different outcomes, it hovered right around 30%, very consistent with what we found in the Middleman project and also with the Laura Gitlin Beat the Blues project. For this paper, I'm going to dive into a little bit and just show some examples of how we actually analyze these effects using the M+ statistical software package. So the next two slides are just going to show you the analysis we did for this first line of the table 4, where the outcome is total kilocalories burned as measured by accelerometry, and the mediator was age stereotypes, a self report measure about the expectations of reduced functioning due to aging. So here is the M+ program. This is the complete program, so you can see it's pretty short. You don't need a whole lot of lines. We did calculate these change scores prior to building the data set, so the change scores are already part of the data set that we're reading here, the CSV data set. But we used in this analysis group, which is intervention versus control, the difference in the kilocalories burned from 8 weeks minus baseline, the baseline kilocalories burned, the baseline aging stereotypes, and then the difference in aging stereotypes from 4 weeks minus baseline. We did an analysis where we asked for 10,000 bootstrap samples, and then under the model statement there, you can just see the two basic regression equations. Let's regress the mediator, changes in aging stereotypes on baseline aging stereotypes, and the group indicator, intervention versus control. And then secondarily, let's regress the outcome at 8 weeks, difference in kilocalories on the baseline of the outcome before intervention, the change in aging stereotypes, and the group indicator for intervention versus control. Then we ask M+ to model the indirect effects of group on the changes in kilocalories burned. And then in the output statement, we had this magical little statement, CINT BC bootstrap, test the indirect effect using a bias-corrected bootstrap method. That's all you got to do to tell M+ to run this thing 10,000 times, calculate those bootstrap standard errors, and print it out in your output. So that's the whole program. This is not the whole output. You get 7 pages of output, so you got to kind of know where to look. But we use the standardized model results, the so-called STDYX, standardized on both the outcomes Y and the predictors X. And you can see that this is the A path, the effect of group on changes in aging stereotypes. This is the B path, changes in aging stereotypes as predicting later changes in kilocalories burned as measured by accelerometry. This is the C prime path, the group still having a significant effect on kilocalories burned after accounting for the mediator. So this is a case like most of the projects I'm talking about today, where there was some significant mediation, but it was only partial mediation. There was still some significant unmediated or direct effect of the intervention condition on the outcome, even after accounting for the mediation mechanism. And then finally, here's the indirect effect and the bootstrap standard error on the indirect effect. And again, although I'm not reported here on this output, if you just take the indirect effect error of 0.057 and divide it by the total effect of 0.174, you determine that 33% of the intervention's effect on changes in kilocalories burned as measured by accelerometry could be explained by the intervention's effect on changes in aging stereotypes, that particular motivating mediating factor that was one of several that we tested in this project. Now, I want to shift gears a little bit and talk a little bit about power analysis for mediation modeling. This is a question that comes up a lot. Okay, I get the point here. I don't want to just do intervention efficacy examination. I also want to test for mechanistic hypotheses and collect some mediation variables. But does that change my power analysis? What do I got to do to properly power these kinds of analyses? And one paper that I found extremely helpful, this is a little bit of dated paper now, but this is a paper from 2007 by Matthew Fritz and David McKinnon, published in Psychological Science, where they talk about some of the considerations involved in having an adequate sample size to test a mediation effect. And a really helpful table in this paper is table 3, where they lay out the sample size that provides 80% power for all kinds of different mediation and outcome effect sizes. So all these analyses are assuming just one mediator and just one outcome, and looking at the effect sizes ranging from small, which is a standardized effect of 0.14, to medium 0.39, to large 0.59. And they also were kind enough to give us what they call halfway, H, that is halfway between the so-called small and so-called medium effects. If you looked at if you're able to remember from the previous slides where I reported some standardized effect sizes from Laura Gitlin's project and from Manfred Deal's project, you saw that many times the effect of the intervention on the mediator was a little bit stronger than the effect of the mediator on the outcome. And indeed, many times they're all in the 0.3 to 0.4 range. So one part of this table I'll highlight is the different sample sizes that you would need if you want to have 80% power to detect this halfway effect between a standardized effect size of 0.26 from the intervention to the mediator and from the mediator to the outcome. You can see that those sample sizes range from from 196 if you plan to use the Sobel method to test the mediation effect, down to say 148 if you plan to use the bias-corrected bootstrap as provided by M+, and probably from other structural equation modeling packages as well. And this illustrates, again, the Sobel test, while very commonly used, is to some degree underpowered, a little bit more likely to give you a type 2 error. So you need 148, about 150 people if you think that both the path A and path B have effect sizes, standardized effect sizes of about 0.26, which they characterize as halfway between a small and a medium effect. As I mentioned, sometimes you can get away with the expectation, perhaps, that your intervention is going to have a stronger effect on the mechanistic mediator variable and perhaps a little bit weaker effect on the primary outcome that is sometimes measured further out in time from the intervention as well. And indeed, if you look at the effect sizes from all 3 of the projects I'm talking about today, Marian Middleman's NYU Caregiver Intervention Project, Laura Gitlin's Beat the Blues Project, and Manfred Deal's Aging Plus Project, you'll see all 3 of those projects had that pattern. The intervention had stronger effects on the mediators than they did on the primary final outcomes. So if you look at the MH column here, where M is a medium effect with the intervention on the mediator, and H is a halfway between the small and medium effect for the mediator on the outcome, you can see then that you need, less than 150, or in the range of 130 or so participants to adequately power that mediation analysis, in precisely 116 if you're planning to use a bias-corrected bootstrap. So this paper serves as some nice reference points of reasonable effect sizes that I think is a good starting point as you're trying to do power calculations for mediation modeling. You can see that if you have very small samples down in the 50 or 60 range, then you're going to need to have at least medium, if not large effects to adequately power your study to test the mediation mechanisms with that kind of sample size. Sometimes pilot studies are not designed to test the entire mediation pathway or the entire mediation model, but to look at specific estimates for some of those pathways as well. So I understand that sometimes pilot studies are smaller in scope and more targeted in their goals. But when you get to the point where you are testing full mediation models, it's a good idea to keep these guidelines in mind. It's not an accident that most of the projects I've worked with have had at least 200 people, sometimes more, so that even after attrition, we're well north of these numbers so that we have adequate power to test reasonable expectations for these mediation effects. Now, I'm going to return briefly to the Mary Middleman project to illustrate some consequences when you make different modeling decisions. So we saw this slide before. This is just pointing out that I'm going to, in the next few slides, we're going to talk about some additional analyses that were done with the NYU Caregiver Intervention Project, where again, we looked at this rather simple measure of satisfaction with social support, just 3 items measuring how satisfied these spouse caregivers were with their social network, with the assistance they received with daily activities, and with the emotional support they received from that network. And as I explained before, when we looked at changes in satisfaction of social support as a mediator of changes in depressive symptoms as measured by the Geriatric Depression Scale in this project, we found that 30% of the intervention's effect on changes in depressive symptoms could be explained by the intervention's impact of changes in satisfaction with social support that were then transmitted on into changes in depressive symptoms. With those same data, if you analyze the 12-month satisfaction with social support and the 12-month depression symptoms, still with baseline as a covariate for both of them, but not analyzing change scores now, analyzing post scores, you actually find that the percent mediated statistic goes up substantially from 30% to 50%. So if you compare this slide to the previous one, you'll notice again that the A path, the effect of the intervention on the mediator, is the same, 0.687, and statistically significant. But the B path and the C prime paths differ and are stronger. Well, the B path anyway is stronger for this analysis of post scores than it is for the analysis of change scores. So you might think, well, heck, maybe we should use post scores then, you got stronger effects. But I would argue that this effect then between the mediator, satisfaction with social support, and depression at 12 months, when you just look at that correlation, you're including a combination of time-varying changes in satisfaction with social support and depression that could be due to the intervention itself, and more static time-invariant associations between satisfaction with social support and depression that have nothing to do with changes that might have been caused by the intervention. And those associations between satisfaction with social support and depression that have nothing to do with the intervention might be due to all kinds of other factors, socioeconomic factors or other confounders. Maybe you can control for those with additional covariates, or not. So I am increasingly a big believer that when you have baseline available for mediators and outcomes, you should be analyzing these change scores as mediators and outcomes, not the post scores themselves, because then you're specifically zeroing in on actual changes in the mediation process and changes in the outcome and forcing those changes to be correlated with each other and not perhaps capitalizing on sort of time invariant associations that might also be present for those measures. So even though the percent mediated was stronger for the observed post score than for the change score, I still like the change score analysis better because it zeroes in on changes that could have been caused by the intervention itself. Now, this leads me into another point about the reliability of the mediator. A key assumption of most multivariate causal models, including mediation modeling, is that all predictors, including the mediators, are measured without error. And Monte Carlo simulation studies, such as those conducted by Hoyle and Kenny, more than 25 years ago now, have shown that even a small amount of unreliability in the mediator can introduce some serious estimation biases on these pathways. And these biases typically inflate the type 2 error rate, that is reduced power for the mediated effect. And perhaps more importantly, they inflate the type 1 error rate or the false positive rate for the direct or the unmediated effect of the intervention on the outcome. So to the degree that you have mediators with less than perfect reliability, you're sort of biasing the analysis away towards finding a mediated effect and then overestimating the unmediated or direct effect. So you might falsely conclude that, gee, this mediator didn't really do anything, or the vast majority of this intervention effect on the outcome remains unmediated, when some of that is a statistical artifact due to unreliability in the mediator. So what do you do about that? Well, one thing is only use mediators that have really strong psychometric properties. And I mean really strong. You want reliabilities 0.8 or even higher if you can get them. And I think the three Likert type ratings that we use in the Middleman project, they had pretty satisfactory reliabilities, but perhaps not that strong. So if you're going to use observed mediators, try to pick measures of those mechanistic processes that have really strong psychometric properties. Another option is to get multiple measures of the mediating process, the mechanistic variable of interest, that are hopefully correlated with each other, at least to a moderate degree, and then extract a latent variable for that mediating process. You could extract latent variables of the actual measure at a certain time wave, or you can extract change scores for those multiple mediators and then extract a latent variable from those different observed change scores. The advantage of latent variables is that you're essentially creating or constructing a variable from those correlated components of those individual indicators, and you end up statistically constructing this so-called latent variable that is theoretically measured without error at all. So has at least close to perfect reliability if you buy into the statistical assumptions about how error is random and uncorrelated. We tried that with the Middleman data, and I actually was the lead author on a paper that published these findings that is in Psychology and Aging years back. It's also part of the references that I'll share toward the end of this talk, where we extracted a latent factor from these three different items. So in this case, M1, M2, and M3 are those three individual item rating scales for satisfaction with social support in general, with satisfaction with assistance, and satisfaction with the emotional support you receive. So instead of just adding them up into a composite score, we extracted a latent variable from those three individual observed changes. And when I did that, I found, and it looks like I can't really see because the panel's in the way here, but we found that 79% of the intervention's effect on change in depression could be explained by this latent mediation process of satisfaction with social support. And even more importantly, the now unmediated or direct effect of the intervention condition, the NYU caregiver intervention on changes in depressive symptoms was no longer statistically significant. So in this case, we really could say that the entire intervention effect on changes in depression could be explained by that intervention's effect on changes in satisfaction with social support, as long as you used a latent mediating variable to fully capture that mechanistic process. Now, one thing that might be a little unsettling to some people, I find it kind of interesting, but sometimes a typical mediation question is what percent of the intervention's effect on a primary outcome variable can be explained by that intervention's effect on a mediating mechanism? Well, in today's talk, I've used the exact same data for Mary Middleman's project in three different ways, and I've shown you that I can calculate that indirect effect or that percent mediated effect ranging all the way from 30% to 69%, depending entirely on the specific analytic method used. And if you just compare mentally, the change from 30% to 69% is simply a difference of using the composite change in satisfaction with social support to extracting a latent variable from those three items too. So simply adding them up, 30%, extracting a latent variable and only using their correlated common components drives that up all the way to 69%, which I think illustrates rather nicely just how strong of an effect the lack of reliability on a mediating process can have on estimating some of these mediation metrics. In all examples, the mediation effect was significant, but only in that latent variable case were we able to say that the more than a majority of the intervention's impact on depression was explained by its impact on satisfaction with social support. I realize I'm close to the end, so I will briefly point out by saying that one other paper we did, we looked at mediation in a time to event outcome, the effects on nursing home placement, and we found using time varying predictors from Cox proportional hazard models that's laid out in this paper published in Neurology back in 2006, that satisfaction with social support, response to behavior problems, and symptoms of depression collectively accounted for 61% of the intervention's impact on nursing home placement. I want to briefly point out that this talk builds, I think, rather nicely on the talk Jeffrey Burke gave to this group just a few months ago on the climber checklist for conducting mechanistic research on behavioral change. In particular, this is a slide from Jeffrey Burke's talk, although he didn't talk about latent variables at all. There's that mechanism with an oval and 3 different indicators, pretty much the same model we used in the Mary Middleman project. And one of his slides talked about common challenges. If possible, the mediator should occur in time between the predictor and the outcome. I do believe that's an important innovation that you should build in if you can. And you might consider measuring changes in the mediator and changes in the outcome. I've also, I hope, made it clear that I do think that's the optimal approach. I'm going to wrap up here with just a few summary key points. I do believe that if baseline values are available for the mediator and the outcome, you should use them as covariates and then analyze change scores. And the bias corrected bootstrap method usually provides the most power for testing the significance of the mediation effect. If your overall treatment effect is not significant, don't quit. Go ahead and test mediation. It may still be statistically significant and interpretable. In that case, the interpretation is, hey, maybe this intervention does work if it moves the mediator, but if it fails to move the mediator, it doesn't seem to be a helpful tool to affect the outcome you're shooting for. And as I pointed out here toward the end, unreliability and measurement of the mediator can massively undercut power. So pick mediators with strong psychometric properties or consider getting multiple measures and extracting latent variables. Here's my favorite model if you just use observed measures using change scores, and my favorite model if you're able to extract a latent variable of the mediation process. Here are the methodological references that I referred to in today's talk. And here are the publications of the applied examples that I went through. So I realize I'm wrapping up rather quickly, but I think all of you know you can access these slides and view this talk offline at your leisure. So thank you for listening to me. And I think I still did leave a few times to take questions.
Yeah, thank you, David. That was really fabulous. And you've given us so much to think about and a very nuanced, sophisticated understanding of mediation analyses. And the bottom line from me is to consult with you when doing these models. But I always learn a lot, and thank you. I'm going to go right to I have some questions myself, but I'm going to go right to the questions in the limited time we have. And the first one was from Dr. Riddle. If I understand correctly, the analysis in the Middleman caregiver study treated satisfaction with social support as a mediator, explaining the effect of the intervention on depressive symptoms. Would it be accurate to think of a mediator analysis as a sort of manipulation check on the intervention delivery? In this case, did the intervention actually improve social support as intended and as measured by satisfaction with social support? So multi-leveled question here, and I don't know.
Yeah, I think that's a great question. I think the general answer to all those points is yes. You know, many times when people are designing interventions, especially in the caregiving space where I work, lots of times we're designing interventions that have multiple components. And I would say changing the social support network was the main component of the Middleman project. But I've worked with others like you, Laura, and Joe, and others where we have multiple components, realizing there are probably different pathways by which the intervention might ultimately improve depression or quality of life or prevent nursing home placement, other potential outcomes. So it's great that you have this theory of these different mechanisms. And I would say, yeah, try to then collect measures. You know, you might think of it as sort of manipulation check measures. Did my intervention really move the components that I thought they would move? Yes, that's important to confirm in its own right, but then they can also serve as those indicators to test that mediation or mechanistic hypothesis. So I think that's a elaborated answer to say yes to all the components of Dr. Riddle's question.
Yeah, so could you think of it too as a mediation of the mediator?
Well, I mean, there are, you know, you could if you had, I mean, sometimes you have multiple chains, so you have, you know, really proximal sort of manipulation checks, then sort of secondary mechanistic changes, and then final primary outcomes. So yeah, I've only kind of focused on one mediator and only kind of three waves, but you can extend, if you have a causal model and enough measures to support it, you can certainly extend it out in more complex ways. I think your question also reminds me of something that I focused only on mediation. There's also this whole other question of moderation. Does the intervention work better for some subgroups than others? And most people conceptually and rightfully so, keep questions of mediation entirely separate from questions of moderation. But when you're looking at mediators with change scores and the baseline level, you can only move the mediator to some extent the people who are most vulnerable at that baseline measure of that mediating process. So sometimes you can have mediation because of moderation, or mediation and moderation. So this is sort of the elements and basics of mediation, but it can certainly be made more complicated to sort of go along with a more nuanced or elaborate causal model. Yes.
Yeah, thank you. Okay, I'm going to try to get through other questions that are coming in. Are these change scores simple difference scores or post scores minus pre-scores?
Well, yeah, both. I mean, they are simple post minus pre scores. I I will add, I think, an important reminder that I like change scores, but only when you then also use the baseline as a covariate. Analyzing change scores by themselves without adjusting for where the change started from, the baseline, I think usually introduces, probably more noise and, sort of some biases due to what some people refer to as the law of initial values. How much you can change partly depends on where you're starting from. So so yes, they're simple. Post minus pre change scores are different scores, but I almost always adjust for those using a baseline covariate approach.
Okay, great. Another one from Dr. Murphy. In the DEAL study, was there adjustment for multiple comparisons of the p-values for the 108 studies?
No, there weren't. I mean, you can easily do that mathematically. The problem with doing like a Bonferroni adjustment is they assume that all 108 of those models are statistically independent of each other. If you use a straightforward, divide the p-value by 108. That's not the case. They were the same variables being recycled in different combinations, and those variables are correlated with each other. It is possible to do a more sophisticated adjustment. We chose not to do so. This also came up in our interactions with the reviewers. Our point was to be descriptive as to which mechanisms appear to be promising to pursue in future research. So I don't like that word exploratory, but some people might use that word. I would use the word more descriptive and granular, and we laid out all those as limitations and important cautionary factors in our discussion section.
And well, a related question then is, were they pre-specified mechanisms that you were looking at and theory based, or was it
Yeah.
in that sense truly exploratory?
No, they were not exploratory in terms of, hey, we collected a bunch of measures, let's just grab some. Manfred built this intervention right from the beginning, targeting to move these processes. And, in some ways, the intervention was really targeted directly at these motivational factors. And then there are different health-related outcomes that, changing motivational factors might affect downstream. We looked at physical activity. You can also look at diet and other health behaviors, smoking and sleep and so forth. So the intervention itself was built to change these motivational factors, and all of that was a priori picked and designed with that purpose directly in mind.
Good. I think it's an important point. Thank you. From Dr. Petrosky, could wearable continuous data be used as a mediator in a clinical trial?
Yeah, I mean, I think any variable, is I think eligible to use as a mediator. So the question to me is, what are the properties of the measure that variable is going to provide? Is it a reliable measure? Or, can you calculate different scores? Are you also able to collect that measure at baseline? You don't necessarily have to have a baseline measure to use something as a mediator, but then you don't have anything to covariate adjust or anything to calculate differences from, but you could still potentially use that as a mediator. Yeah, I think any well-measured, that is with strong psychometric properties, particularly reliability, internal consistency, however you want to gauge that, any measure after intervention that has those properties could be used as a mediator. The question then becomes, does your causal model in your theory, you know, designate that as an important mechanistic process by which you're affecting some other more primary or long-term, you know, downstream outcome.
Wonderful. Great. Thank you. Well, there are still 3 questions, but we're not going to get to them. And I'm wondering, Katie and or Robin, if they could be sent to Dr. Roth so he could respond to them outside of this webinar, because I think there are important questions.
Absolutely.
Yeah.
Yeah, good, great. Okay, well, I just want to say thank you so much again for this incredible talk. The slides will be available and the talk will be recorded and available on our website. Remember that we're asking you to conduct a survey. I believe it's in the chat. Is that correct? The link? And
it is.
Yes, it is.
Yes,
Okay.
yeah, it's in
Yeah.
the chat.
And that QR code takes us to the website. And then please stay tuned because we'll continue this mechanistic discussion and also look at mechanisms from a statistical point of view with Dr. Allure, who will join us October 23rd. And again, a round of applause, Dr. Roth. It was a master class you gave us. Really appreciate it. Thank you so much. And thank you everybody for joining.
Thank you. Robin or Katie, if